Welcome to Bookscape Epic Reads, where we dive deep into the world of popular books, exploring timeless classics and modern bestsellers alike. Join us for in-depth reviews, insightful discussions, reflections. Let roll. The Structure of Scientific Revolutions by Thomas Kuhn is one of the most transformative works in the philosophy of science. Originally published in 1962, Kuhn's groundbreaking book fundamentally altered how we understand the evolution of scientific knowledge. It challenges the traditional view that science progresses through a steady, cumulative process, instead proposing that science undergoes periodic revolutions. These revolutions are shifts in the foundational paradigms that guide scientific thought and practice, radically changing the way we perceive and understand the world. In Kuhn's view, scientific progress is not a smooth, linear path, but a series of dramatic paradigm shifts, each one reshaping our intellectual landscape. At the heart of Kuhn's argument lies the concept of paradigms, the broad foundational frameworks that define scientific practice in any given era. A paradigm is not just a collection of scientific theories or facts, but a comprehensive worldview that encompasses methodologies, accepted norms, and shared assumptions within a scientific community. These paradigms function as a guide to normal science, providing the structure within which scientists work. Kuhn explains that paradigms shape everything, from the questions that are asked to the methods used to answer them, as well as the interpretation of results. For Kuhn, paradigms are essential to the functioning of science. They provide a shared set of assumptions that allow scientists to carry out research efficiently, providing a common language and a set of standards by which scientific work is judged. However, these paradigms are not static. They evolve over time as new discoveries or anomalies arise. As long as the paradigm continues to explain the majority of the phenomena being studied, it remains dominant. But eventually, as anomalies, observations that cannot be explained by the existing paradigm begin to accumulate, the foundation of the paradigm starts to crack. Kuhn introduces the concept of normal science, which represents the typical period of scientific activity where research is conducted within the constraints of the existing paradigm. During this time, scientists do not question the underlying framework, but focus on solving problems that arise within it. Sebelum lanjut, don't forget to comment, like, and subscribe. Normal science is not about revolutionizing the field. It is about refining and expanding the paradigm by addressing known issues and pushing the boundaries of the accepted knowledge. Within the context of normal science, the work of individual scientists tends to be incremental. They test hypotheses, develop experiments, and work with existing theories to deepen the understanding of natural phenomena. Importantly, Kuhn emphasizes that during periods of normal science, there is no need to radically rethink the world. The paradigm's foundational assumptions remain largely unquestioned. However, Kuhn warns that this period of stability often leads to the accumulation of anomalies, data that does not fit within the framework of the prevailing paradigm. As research progresses under the umbrella of normal science, anomalies inevitably begin to appear. These anomalies are pieces of data or observations that do not fit within the current paradigm. They are not necessarily dramatic at first, but they begin to accumulate over time. Initially, scientists may attempt to explain away these anomalies, or view them as exceptions that do not fundamentally challenge the paradigm. However, as these anomalies become more pronounced, they begin to undermine the credibility of the existing scientific framework. Kuhn notes that when a critical mass of anomalies builds up, the scientific community enters a phase of crisis. During this crisis, the prevailing paradigm no longer seems capable of explaining the full range of phenomena, leading to a sense of intellectual instability. Scientists begin to question the paradigm and look for alternative explanations. However, Kuhn makes it clear that this phase is not one of immediate consensus. Scientists may either try to patch up the old paradigm, modifying it to accommodate the new data, or they may begin searching for an entirely new framework that can account for the anomalies. Sebelum lanjut, don't forget to comment, like, and subscribe. The critical turning point in Kuhn's theory is the scientific revolution, a dramatic and fundamental shift in the dominant paradigm. During a revolution, an entirely new framework of thought emerges, replacing the old paradigm. This new paradigm not only explains the anomalies that the old one could not, but it also offers a new set of rules, methodologies, and assumptions that change the way science is practiced. Kuhn argues that scientific revolutions are not gradual or incremental. They are discontinuous events that represent a radical break from the past. The old paradigm is no longer sufficient, and the new paradigm offers a radically different way of understanding the world. This shift is not always smooth. Scientists who adhere to the old paradigm may resist the new ideas, and debates between the proponents of the old and new paradigms can be intense. The transition from one paradigm to another is not simply a matter of adding more facts to the old framework. It requires a profound rethinking of the fundamental principles of the discipline. A famous example of a scientific revolution is the shift from Newtonian physics to Einstein's theory of relativity. This shift did not merely add to existing knowledge, it fundamentally altered our understanding of space, time, and gravity. Similarly, the advent of quantum mechanics revolutionized the way we think about the very nature of reality. One of the most controversial aspects of Kuhn's theory is the concept of incommensurability. This idea suggests that different paradigms are not simply alternative ways of looking at the same phenomena, but rather they are so fundamentally different that they cannot be directly compared or reconciled. When a scientific revolution occurs, the new paradigm often introduces a completely new way of understanding the world, one that cannot be directly mapped onto the previous paradigm. As a result, Kuhn argues that there is often a period of confusion and misunderstanding between scientists who adhere to different paradigms. Communication between these groups can be difficult because the language, concepts, and assumptions that define each paradigm are so different. For example, a physicist trained in classical mechanics may find it difficult to grasp the conceptual framework of quantum physics, as the two paradigms operate according to different rules and assumptions. Kuhn's idea of incommensurability suggests that paradigms are often so incompatible that scientists from different paradigms may be speaking entirely different intellectual languages. Kuhn's book had a profound impact on both the philosophy of science and the broader scientific community. His challenge to the idea of linear scientific progress forced philosophers of science to reconsider the nature of scientific development. Kuhn's view that science is not a smooth, continuous process, but a series of revolutions reshaped our understanding of scientific inquiry and knowledge. His theory undermined the idea of science as a purely objective and rational pursuit, emphasizing instead the role of human judgment, historical context, and social dynamics in shaping scientific knowledge. Sebelum lanjut, don't forget to comment, like, and subscribe. In the wake of Kuhn's work, scholars in the philosophy of science began to rethink the traditional assumptions about the nature of scientific knowledge. Kuhn's focus on paradigms and revolutions opened up new ways of thinking about the relationship between science and society, the role of scientific communities, and the nature of truth in scientific inquiry. Even decades after its publication, the structure of scientific revolutions remains a foundational text in the philosophy of science. Kuhn's insights continue to resonate in discussions about the progress of scientific knowledge, especially in the context of rapid technological advances and emerging fields of research. The idea that scientific knowledge is not a linear accumulation of facts, but rather a complex interplay of paradigms, crises, and revolutions is as relevant today as ever. In a world where new scientific theories and discoveries are emerging at an unprecedented pace, Kuhn's work reminds us that scientific progress is often unpredictable and subject to profound shifts in understanding. Kuhn's concept of paradigm shifts also extends beyond science, influencing fields such as sociology, political theory, and even business management. The notion that change in any field can be sudden, disruptive, and revolutionary has shaped how we think about innovation, creativity, and progress in various domains. Don't forget to comment, like, and subscribe.